Here we're being asked to add an infinite number of values and come up with a sum. So this is a geometric series, meaning the terms are part of a geometric sequence. And so we do have a formula for the sum of an infinite geometric series, and that is the first term, a1, over 1 minus r. But this formula only applies if the common ratio r, the absolute value of it, is less than 1, meaning that we're multiplying by something less than 1. So in other words, the numbers in the list are getting smaller. And so if our common ratio is greater than or equal to 1, then we cannot use this formula. Okay, so we need to check, and since our formula involves r anyway, we need to find the value of r here for this sequence. So to get from 3 to 2, and then 2 to 4/3, and 4/3 to 8/9, we need to figure out what we are multiplying by to do that. And so we just take any term here, I'll start with the second term, and divide it by the previous term. That's how we get our common ratio. So we get 2/3 for the common ratio. And just to double check, if we do 3 times 2/3, then the 3's would essentially cancel and we get 2. And then 2 times 2/3, 2 over 1 times 2/3, so straight across the top would be 2 times 2 is 4 over 1 times 3 is 3, so we'd get 4/3. And then 4/3 times 2/3, 4 times 2 is 8 on top, over 3 times 3 is 9 on the bottom. So 2/3 is our common ratio. And the absolute value of 2/3, of course, is still just 2/3, which is less than 1. And so this formula applies. And so this infinite sum is equal to a1, the first term, which is 3, over 1 minus, our common ratio is 2/3. 1 minus 2/3 is 1/3, so I have 3 over 1/3. So that's 3 divided by 1/3. And to divide with fractions, we would change it to multiplication and flip that second fraction. So it's 3 times 3 over 1. 3 over 1 is just 3. So 3 times 3 is 9. So our infinite sum, so if we added those numbers up forever, we would get closer and closer to 9 and never get past it. And so we say the infinite sum is equal to 9.